Hello, everyone, and thank you for joining us this evening for the seventh week of the RISE Institute and Rugby Research and Injury Prevention Group 2026 Analytics Series. Next intern will be Erin from New York, and we will be presenting on descriptive statistics and standard scores. Erin, may you please share your screen?
Okay, can everyone see my screen? Okay. Hi, my name is Erin. I'm a rising junior at Horace Mann School in New York City, and today I'll be talking about descriptive statistics and standard scores. So first, I'm going to go over what descriptive statistics are. They summarize and describe features of collected data. Um, And they do this without making any conclusions about the population. So if you wanted to infer something about the larger population using your sample data, you would use inferential statistics. And I'm not going to talk about that today, but we've already discussed inferential statistics a lot. So examples of that are hypothesis testing and linear regressions. And if you look at this graphic, it shows the main subtopics that fall under descriptive statistics. So you have central tendency, variability, and frequency distributions. And so those are, alongside standard scores, those are the main topics I'm going to be talking about today. And something else that is important to note about descriptive statistics is that the data being evaluated is usually quantitative. So for categorical data, descriptive statistics are usually limited to counting the frequencies of the qualities. So first I'm going to talk about central tendency, which summarizes the whole data set using a single value that represents the middle of its distribution. And this can help us identify where most of the numbers in the data fall, and it's best applied on continuous data. So using this sample data set of test scores, I'm going to go over mean, median, and mode, which I'm sure most people are familiar with these terms. So first, the mean, it's the arithmetic average of the measurements in the data. So basically how you calculate it is just taking all of the values in the data set and dividing it by the number of values there are. So here I just added all the test scores and then divided by 8 to get a mean of 82. And there's usually only one mean of the data, and the mean is very influenced by extreme values. So if you can see in this data set, we have an outlier of 40. And because of that, it makes the average much lower than, for example, like the median. So it's not very resistant to outliers. And that because of that, the mean is generally the best measurement of central tendency for symmetric distributions, like in this case right here. Next, the median is the middle value when the data is ordered in numerical order, and it's the central value of the set of data. So that means 50% of the data lies above the median, while 50% of data lies below it. And it's easy to identify when there's an odd number of values, but here there's an even number. So all you would do is just take the middle two values and average them to get 85. There's also only one median in a data set, and it's resistant to outliers. So it's a better representation of central tendency of skewed distributions than the mean. So if you look at this diagram of a skewed distribution, you can see that the median appears to be a better representation of the middle than the mean. And finally, the mode is the most frequent or probable value of in the data, and there can also be more than one mode. So you can see here the mode in the test scores is 80 and 95 because they show up in the data at equal frequencies. So if the data was actually graphed out, there would be two peaks since there's two modes. And they're great for continuous data, but they're also good for categorical data. And in other contexts besides test scores, it's great for identifying trends. Next, I'm going to talk about frequency distributions. And so frequency distributions are just like a way to organize and summarize data in a way to show how values are spread across categories. And they can be put in a table or chart. So most people start with a table. And so here's a frequency distribution table. It usually includes four components. So first you have the data intervals or categories. Here it shows values, but it can also be categories such as like people's favorite sport. So this column could be replaced by, for example, soccer, football, basketball, etc. Then you have the frequency counts, which just shows how many times each value or group occurs. Then you have cumulative frequencies, and these are the frequencies and they total up after each value, and they're helpful for finding the median or percentiles. So, for example, there are 25 total values, and given that the table is like the values in the table are in numerical order, I can easily see that the median is 5 because if there's 25 values, then the median is going to be the 13th value, and that would show up right around here. Finally, you have relative frequencies, and these are just percentages that show the proportion of each category. And once you have the table done for the frequency distribution, that can serve as a foundation for a chart. And the most common charts for frequency distributions are bar graphs, pie charts, and histograms. Next, I'm going to talk about another aspect of descriptive statistics, which is dispersion or variability. So measures of dispersion and variability show how spread out the values in a data set are, and that can help you understand whether the data is tightly packed together or if it's widely scattered. And the main measurements of dispersion are range, interquartile range, variance, and standard deviation. So first, you have the range, and very simply, it's just the total spread of your data. So you just have to do the maximum value of your data minus the minimum value. And using our example test scores, you can see it's just 100 minus 40, which gives us a range of 60. And then you have the interquartile range, and that represents the range of the middle 50% of your data. So if you look at this graphic of the box plot, um, you can see that this is the interquartile range, and it's calculated by taking the upper end of quartile 3 and subtracting the lower end of quartile 1. So again, using our test scores, we get an IQR of 17. And these two components are important because although we can get a central tendency, which gives us a central location, by having dispersion, it can identify the shape of our data. Then two other aspects of dispersion are variance and standard deviation, which quantify the horizontal spread of the data, basically how spread out the values are from the mean. And if you look at this diagram right here, you can see that when the data is more clustered towards the mean, it will lead to a low standard deviation, while if the data is more spread out, that will lead to a high standard deviation. And here is the formula for standard deviation. And the formula for variance is just inside of this formula. It's under the square root. And so the formula looks really complicated, but it's pretty simple once the process is laid out. So I'm going to go back to our example data test scores, and I'm going to walk through how to calculate the standard deviation. So first you just take all of the individual data points, and I couldn't list all of them out here, but these are just the individual test scores, and then you would subtract the mean of the data set from each one. And you can see that these values, some of them are negative and some of them are positive. So then you square these values and add them up. And once you add them up, you divide them by the number of data values subtracted by 1. So I would just take the total of these values and divide it by 7 to get a variance of 362. And then once you square root the variance, you'll get around about 19.0, which would equal to 1 standard deviation for this data set. So what does this mean? It means that on average, a student's score missed the mean by around 19 points. So that means most students scored between 63% and 101%. And if you look at this normal distribution curve, it helps you understand standard deviation a little better, you can think of standard deviation as steps. So say this is the mean, and then if you are within one standard deviation, you're looking at around 68% of the population that you have. Once you go two standard deviations from the mean, then you're starting to look at 95% of your population, etc. So I wanted to talk about standard deviation last because standard scores are a direct application of standard deviation. So a standard score compares a test taker's performance to same age peers, or similar test takers, and they don't represent the amount of ability, knowledge, or skill that a person has. Rather, it just compares a person's ability, knowledge, or skill to that of similar people. So you have standard a common standard score is the z-score, and this is the calculation for it. It just tells you how many standard deviations from the mean your raw score lands, which can tell you how you did compared to similar test takers. So here's an example from the IQ test. So say you got a raw score of 130, and the mean for the IQ score is 100, and the standard deviation for the IQ score is 15. So using this formula, we get that the student has a z-score of 2.0, and that means the student scored two standard deviations above the mean score. So if you see here, if we go two standard deviations up, we get to 130. And this is this can just show how well you did compared to other test takers. And once you start getting standard scores, you can start looking at the percentiles. So you can see that a score of 130 is the 98th percentile, which means you did better than 98% of all of the test takers. And something else that standard scores are useful for is that they can compare raw scores of two completely different tests. So, for example, the SAT and ACT have two different score like scoring methods, but by using standard scores, you can see how many standard deviations each score is from the mean to compare test takers. So here are the key takeaways from this presentation. Descriptive statistics help summarize large data sets into understandable concepts, and these are the main four subtopics of descriptive statistics. You have the central tendency, which shows the typical value in a data set, your frequency distribution to identify patterns or outliers and see how often values occur. You have your dispersion, which reveals how spread out or varied the data is, and you have the standard scores, which allows you to compare raw scores to the rest of the data set. These are my references. Thank you. Does anyone have any questions?
Thank you for that excellent presentation, Erin. Are there any questions, or Dr. Lopez, do you have anything to add?
Aaron, I just sent you a small blurb of something. Why don't you open that up in the email? Why don't you tell us a little bit about what I brought up there? I think it's kind of interesting. They bring up descriptive statistics, but oftentimes they almost jump over this important aspect of frequency versus prevalence versus incidence. Why don't you go over what the difference between frequency and prevalence is? That's the most important, the first two. And then you could discuss maybe the incidence versus prevalence, and then obviously how it goes into birth.
Okay, so well, from here, frequency is how often a disease occurs. Incidence is measuring how many new cases there are per specific period, and then prevalence is like all the existing cases at a specific point. So I guess if you're asking for the total burden, then you would look at the prevalence because it's counting all of the current existing cases in a specific time.
Yes, thank you. More importantly, as you see, All of these are mathematical ratios and formulas which they have relationships to each other. And I think oftentimes people jump over the importance of prevalence versus incidence. And meanwhile, if you look down at the bottom there, prevalence is actually incidence by duration for burden, right? Explain the relationship between the two. So obviously, it's something that we've already talked about, understanding between who gets it, or if you who has it, who could potentially get it, right? So I think you could think of it in that way, and then obviously how it affects the population is your overall burden. Anyway, it's always surprising how often they forget these basic formula or these basic discussions in the topics. Okay, thank you, Erin. Good job.
That will conclude our call for today. We thank everyone who joined us for our RISE Institute in Rugby Research and Injury Prevention Group Analytics series. Thank you to everyone for joining us.